So today you're going to learn about parallel and perpendicular lines. Hopefully you should know what those things are. Okay, you've studied those kinds of lines way back in elementary school, but in case that has slipped out of your brain, I'm going to reteach what those lines look like, and then talk to you about some of the properties of parallel and perpendicular lines. Okay, so in case you forgot, a set of parallel lines look like this. Right? They go on forever in either direction, and they never touch. Okay? They're like that one girl you like in high school that you're always trying to get closer to, but she just keeps you at arm's length. You know what I'm talking about?
Friend zone.
Friend zone, right? That's what this space is right here is. This is called the friend zone. Okay? Not allowed to get closer. But you also don't want to see her go apart from you, so you don't let her get too far away from you, right? You always keep in touch. Is that what the kids call it nowadays? Keep in touch. Right? You like all their statuses on Facebook. You do that dumb poking thing. Is that still a thing?
Yeah, I do.
Can you still poke people?
Yeah.
Oh, yeah.
You can. I do it all the time with Jasmine and Sharon.
Okay. Right? Maybe send them a message during the summer. Hey, how's your summer? Want to hang out? Right? Just to keep that flicker of hope alive. So those are parallel lines. Two lines that follow each other into infinity, never get closer, never get further. They always stay the same distance apart. Okay? Perpendicular lines look like this.
You broke the friend zone.
Okay? They are intersecting lines, but they intersect in a special way where the angle that they make at the point of intersection is 90 degrees, or a right angle. Right? I mean, you can intersect lines like this, but the intersection point does not create a 90-degree angle. Perpendicular lines are unique in that when they cross, they make a 90-degree angle. And they make it like everywhere. It's not only on that side, it would be here as well, and here, and here. You get a box. Yeah. They're all 90 degrees. Okay? Make sense?
Yes.
Is that familiar?
Yep.
I hope? Okay. Good. So, we're going to graph parallel and perpendicular lines.
Nice.
And try to figure out if their equations have anything in common. Okay? So I created 10 equations here that I created. Some of them are parallel, some of them are perpendicular, and some of them are neither. Okay? What I want you to do is to choose a set of lines and graph them and tell us whether or not they're parallel or perpendicular. So let's just assign some. So Darren, I'll get you to take this one. And Domino, Haley, and Stephanie. And I'll do the last two. Okay, so graph your pair of lines. I would recommend when you graph your lines, do these two commands. Okay, you guys with me? Press, after you have your equations put in, press Zoom 6 to get standard window settings. After it graphs, press Zoom 5. Reason why is because you know how your screen is wider than it is tall? So all your graphs originally on Zoom 6 are stretched. They're fatter than they should be. So to make them not fat, make them look like they should, Zoom 5 fixes that. Okay, so Zoom 6 and then Zoom 5. Okay, so graph those equations and just raise your hand when you've got it. Okay, make sure you copy these down, guys. This one would be neither. And this one would be perpendicular.
And can you tell that just from looking at the equation?
I can tell that looking from the equation.
How can you? Will we be able to do that one day?
You will be today, in fact.
Oh, goodness.
In fact, in the next 5 minutes, you will gain that ability.
I'm scared.
Oh,
You will level up.
oh.
So I want you to look first at the lines that are parallel. So that's these guys, these guys, these guys. Just look at the, I know, I can tell just by looking.
Because they have the same numbers in the first for X.
What's similar about all of those pairs? What do you notice?
X is the same, one's
No,
positive,
no. X is not the same.
The
Use the right term.
Oh,
What is that coefficient?
Intercept.
What's the coefficient in front of X called?
It's the same.
The slope. Thank you.
The slopes are all
The slope
same.
is the same.
Slope is the same.
That's how I can tell. Right? If the slopes of two lines are the same, they're parallel. And it makes sense, right? Because it's not there. If you look at these two lines, if their steepness was any different, they would cross at some point. Right? Like if one line was just a little bit steeper than the other, come a little bit steeper than the other, right? And you went on into infinity,
They touch.
they would touch. And they'd also get further apart if you went the other direction. So even if their slopes are just slightly off, they're not parallel anymore. So that makes sense, right?
Mm-hmm.
Okay. So if you go to the next page, it says parallel lines have the same slope. But what's different about them? The y-intercepts, right? But different y-intercept. Make sense?
Indeed.
Let's look at perpendicular lines now. Okay? So perpendicular lines, these were this one, and this one, this one, this one, and that one's a little harder to tell, but what do you notice here? Pardon me? Not necessarily. This one doesn't have a fraction. Look at their slopes.
They're different.
The slopes are different, but do you see any kind of commonality?
Your your common denominator is equal to your slope.
No.
The denominator on one is equal to the numerator on the other.
Yeah, right? If you look at, where's a good example of that? Right here. Look at this one. Okay? You've got 4 over 3 for one, and then negative 3 over 4 for the other. They both use 4 and 3. It's just one is upside down compared to the other. And one is positive, and the other is negative. Right? Does that happen here as well?
Yeah.
Yeah, you have one positive, one negative, and one is flipped over from the other. What about for the other ones? Let's look at Darren's here. One's positive, one's negative. Is this the flipped over version of 3?
Yeah.
Why?
Because 3 over 1.
Yeah, because technically this is 3 over 1. And you flip it over, you get 1 over 3. Right, does that still hold? What about here? One's positive, one's negative. 1 over 2, 2 over 1 technically. Okay, there's a special name that we use for that. Okay, called a negative reciprocal. Okay, so I'll write that down. So perpendicular lines have slopes that are negative reciprocals of one another. Okay. So negative reciprocal. Let's talk about that just for a moment. So if I had just the slope or the number, say 5 over 6, the negative reciprocal of that would be throwing a negative in front of it, so negative 5 over 6, and then reciprocating it, meaning you flip it over. Right? The top becomes the bottom and the bottom becomes the top. So that becomes negative 6 over 5. So this is the negative reciprocal of this. Make sense? If you had, say, 7, the negative reciprocal would be what?
Negative 1 over 7.
Negative 1 over 7, because technically this is 7 over 1. Negative would be negative 7 over 1, and then reciprocating it would be negative 1 over 7. Right? So that's the negative reciprocal of that. See how that works? Okay? So that's how you know you have a pair of perpendicular lines. Their slopes are different, but they share a common characteristic in that they are negative reciprocals of each other. I guess one more I should mention. If I had -5 as a slope, what would be the negative reciprocal? Positive or negative?
Positive.
Be positive 1 over 5, right? Because you throw another negative sign in front of that, and those negatives would make a positive, right? And then reciprocate it, you get 1 over 5. So that's the negative reciprocal of that. Good? So, let's say we had a line given by the equation y equals -5x plus 8. Could you give me an equation that would also be parallel to that line?
Yep.
Give me one.
Y equals -5x plus 3.
Yeah, sure, good. Are there other possibilities?
It's on
Someone give me another one.
y equals -5x plus 2.
Plus 2, okay. One more?
Do you have negative, like say 6?
Yep.
Be negative?
All of these lines are parallel to that guy, right? We know they're parallel because they all have the same slope and different y-intercepts. What would happen if you had the same y-intercept?
Would be on top of it.
Yeah, they would lay on top of each other.
Friends when you're in the friend zone.
Let's say you had a line y equals 5 over 6x minus 1. Could you write an equation that is perpendicular to that line? What would it be?
Y equals -6.
-6 over 5x.
Plus 3.
Okay, plus 3.
Does it matter what your y-intercept is?
Yeah, does the y-intercept... We didn't talk about that. Does the y-intercept matter this time?
I highly doubt it.
It doesn't matter. You could have -1. They'll just cross at the same place. They'll cross at -1, but that's okay. Right? And the options are endless. But the point is, these guys are perpendicular to what we started with, because we can see that their slopes are negative reciprocals.